Hello, my name is Swami. I'm going to be showing my seventh lab experiment on system software and compiler. So the experiment is about predictive process. So what we're going to do here is we're going to write a Java program that will pass a given string using non-recursive predictive passing for a grammar that the user enters. So here is the algorithm that's given in the question. So we'll do this in a program and we'll try to get the output. As an input we'll give this passing table. So the user will enter the total number of terminals and also the total number of non-terminals, and then he'll give the values of the terminals and also the non-terminals. And for the values in the table, the user will enter each of the transition that it has to be made. So finally this table will be built using all the inputs that is given by the user, and then finally the user will also enter a string. So for example, this is a string. We'll use the passing table, and then we'll make each of the steps, and finally check if the string is accepted by the in this passing table. So this is the question. So let's take a look at the program now. So the program is over here. So initially we're adding all the header files that we need for the program, and then inside the program, so this is the main function. So inside the main function we're using two different scanner objects, S and S1, and we're initializing two variables. There are two different strings, T and NT. So this is for terminal and this is for non-terminal. So initially we're asking the user to enter the number of terminals, and we're storing it in T no. And then we're asking the user to enter the total number of non-terminals, and we're storing it in NT and no. And then we're asking the user to enter the list of terminals. So the user will enter it, and we're storing it in this string, that is T. And then we're asking the user to enter the list of non-terminals, and we're storing it in NT string. So finally we'll get the number of terminals, number of non-terminals, the list of terminals, and the list of non-terminals. And then now so we're creating the table over here, and in the table what we're doing here is so it's a 2D array, and it's the number of rows is the number of non-terminals, and the number of columns is the number of terminals. So we're going to initialize the table, and as you can see, I've used two loops. This will jump onto each of the column, and this will jump onto each of the row. First we are initializing every single like values in the table to null, that is like an empty code, and then we are asking the user to enter the values of the passing table, and as the user enters it, we are storing it in the array using s.nextLine like as the user enters, and then finally the passing table will be printed over here. So the passing table is then we're printing using the for loops. So after it, what we're doing here is so we initially like initializing stack variable as $s, and then we're asking the user to enter a string that has to be passed. So it will be stored in IP, and then we're adding a dollar symbol at the end of the IP, and then we're checking if IP is not equal to $. So if it's not equal to $, it will start passing, and then we're gonna print stack, and then the first value, and then what we're doing here is we're gonna check if we're gonna put the first character of IP into that is the first character of the string that the user entered to a variable called temp, and then we're concatenating that value with the variable C, and then we're initializing a temp again with the stacks the character in the like total number of stack minus like the total length of stack minus one's value, and then what we're doing here is we're giving PWS, which was initially initialized to null, and then we're adding like concatenating temp to that PWS, and then finally we're like reducing the substring of the stack. So the stack will get reduced as it finds it like $, and then finally if C is equal to PWS, so here we've like found out for C, and then here we've found out for PWS, and if both are equal, we're gonna like go to the next line, and then we're gonna initialize IP, that is the string that the user entered to the like substring of it. So we'll remove the values that are given inside C and PWS, and then we're gonna continue. So so what happens here is the parsing techniques will be going on over here, and then it is getting like we're gonna check if the array contains PWS, and then we're gonna check the index of PWS, and then we're storing it in a variable XR, and then if it's not with it, we're gonna set the flag to 1. And then here we are checking if it contains C, and we're gonna if it contains C, we're gonna initialize XC to the value that is present in the index of C, and then if C is not if the array doesn't contain C, we're gonna set the flag as 1, and then finally we're moving to the final part. So here what happens is we're just finding the reverse of the string like over here, and then we're storing it in a variable called rev, and then we're concatenating stack with the reverse, and finally we're printing the stack like the word stack, and then the string that the user entered, and if we're checking if flag is equal to 0, and if the flag is equal to 0, we're checking if IP's current value is $1 and stack's current value is $1. So if both are $, it means that the string is accepted. If both aren't $, it means that the string is not accepted. And finally, if both doesn't happen, it means that the table, like the value entered in the table is wrong. So finally, if the user wants to check another string, we can enter 0 or 1, and then finally we are initializing it in a variable ch, and we're using the while loop. So this was inside a do while loop, and let's take a look at the input. So because this is a long input, I've already typed in. So then the total number of terminals is 6, and the non-terminal is also 6. So this is the list of terminals A, B, C, D, E, and dollar, and the non-terminals over here. So S, A, B, C, D, and E, so this is the passing table. In SNA, the value will be A, B, C, D, E, and for SP the value will be A, B, C, D. So SC the value is A, B, C, D, E, and so similarly we're giving the all the values for the passing table, and as you can see, this is the passing table. And once the user enters the string, so we'll check first initially we're going to reverse it, and then check the for example S and A will give A, B, C, D. So S and A is giving A, B, C, D, E, and then we're displaying A, B, C, D, and then giving the reverse of it to the IP, that is a value that the user entered, and then we're going to check for A and A. So for A and A, it's going to be A, small a. So as you can see, it's A and A, and then for like that the value is going to get passed, and finally $$ is acquired, and then that means the string is accepted. So the program will ask if the user wants to accept another string, and we're going to give no. That's the end of the program. Thank you for watching.